Okay, inscribing a cylinder, we've got a sphere. We want to find the height and radius of the largest right circular cylinder that can be put into a sphere of radius square root of 3, described in the figure. Okay, there's the answer. So you're good to go, right? um, okay, how do we do this? We want to find the largest right circular cylinder that can be put in there. When we're talking largest, we're talking volume. So if I want the largest volume, I want to find the maximum volume. The maximum volume. Okay, so volume of a cylinder is the area of the base, which is pi r squared times the height. Okay, so I want to find that maximum. Problem is, of course, we've got r's and h's. Okay, I need to write one in terms of the other. How are r and h related? R and H related. Okay, that's the $64,000 question. Let me go big here, get some more space. All right, well, oops, and you probably already answered this question. Um, oh, wow. They're related by this right triangle right inside here, right? R, H over 2, because that's just the height, that H is the height of the cylinder. So I know that r squared plus h over 2 squared equals square root of 3 squared by that right triangle inside here. Sorry about that. Okay, so let's solve for one or the other, and since I've already got r squared in my equation, why don't I just solve this for r squared? 3 minus h squared over 9, and then replace that into here. So I've got v equals pi times 3 minus h squared over 9 times h. And since I'm going to maximize it, I know I'm going to take the derivative. Let's multiply it out, make it easy. Pi times 3h minus h cubed over 9. And I do want to keep in mind what's my maximum minimum r. I've got some restrictions here. I know the smallest r could be is r has to be bigger than 0, of course. And I know that the largest r could be is actually the square root of 3, right? The actual radius. So r has to be bigger than 0 and less than the square root of 3. Okay. Same thing with h. The largest h could be, would be square root of, or half of h would be square root of 3. So h over 2 has to be less than the square root of 3 and bigger than 0. So if I multiply by 2, I'm just thinking this, kind of always on the side. I'm thinking, what's the domain? What do I need to worry about? Should it come into play later on? So, volume, v prime, or dv dh, because I'm taking the derivative with respect to h, is pi times 3 minus 3h squared over 9. Set that equal to 0 to find the maximum. V prime divided by pi is 3 minus h squared over 3 equals 0. h squared over 3 equals 3. h squared equals 9. h is 3. Okay, let's set this up. That's my critical point. 3 v prime, v prime. I haven't talked to you about this in class. I did talk to the AP trainer this weekend, who actually is a test writer, and she said the readers don't even look at your sign charts. If this is supposed to be a max, it's going to be a max, and so you can just assume you don't need to check in these types of problems, but on other types of problems you absolutely need to check because you don't know. But just to be on the safe side, I'd like to do that if it's reasonable. So a number less than 3, like 1, 3 minus a third is positive. Increasing bigger than it, like 4, negative. Decreasing, so it's a max. So the max volume is at h equals 3. And what did the problem ask? Find h and r. Oh, I'm reading the wrong problem. It says Find the height and radius of the largest. Okay, so h is 3, and then what do we have? R squared is up here. 3 minus 3 squared over 9, which is 3 minus 9 over 9, which is 3 minus 1, or 2. Did they give us units? They didn't give us units, so we're good. So we got r squared is 2, so of course r is square root of 2. So there we go. Oops. Okay.